can see these 5 questions. We're going to cover 2014 number 1 right now. We completed all of the questions that have to do with, or specifically that cover arrays, and then the array list stuff is what we're focusing on pretty much the rest of this week. So we did 2012 number 1. We're going to cover 2014 number 1 right now. That's a repeat or an overlap between these 2 topics. And then this is the question that I'm going to assign for tomorrow. It's not easy. Okay, I spent a lot of time dissecting this question earlier this morning. So I actually felt like the 2016 exam in general was really was brutal. I thought it was really, really tough. And, you know, look, that could happen this Friday where we get, you know, 2 questions that are really difficult. But again, that's not to say that if from 1 year to the next may be more difficult than the other, but then the curve that they used will be different. Okay, so it's not like they have a set curve in place. It really just depends on, I think, the average scores of the general public taking the exam. Okay, so don't freak out if you get one question of the 2 that is just brutally difficult. All right, let's take a look at the question 2014, which involves strings, which we haven't really dealt with in any of the other FRQs. So it says, this question involves reasoning about strings made up of uppercase letters or capital letters. You will implement 2 related methods that appear in the same class not shown. So again, if you're going to be using an IDE, this question would make it very difficult for you to test your code because they don't provide you with any sort of basic class structure here. All right. So I came up with one on my own, and I'll show that to you in a moment. The first method takes a single string parameter. Okay, so it's fed a string, and it returns a scrambled version of that string. Okay. The second method takes a list of strings and modifies the list by scrambling each entry in the list. Any entry that cannot be scrambled is removed from the list. Okay. All right, part A. Write the method scramble word, which takes a given word and returns a string that contains a scrambled version of the word according to the following rules. Okay, so let's hop on over to Replit real quick. I've got my scrambled strings class, public class scrambled strings. I've imported java.util.list, java.util.arraylist. In fact, I can, if I want to, I can synthesize this and just have import java.util.star. So when in doubt, import java.util.star, and that covers pretty much all bases, all of your bases, and there won't be anything left out there. Okay, so notice I don't have a constructor, I don't have any private instance variables, and that's just fine. And in fact, I'm told that the method that I'm going to be writing for part A is static, so it's a class method, all right? And the method in part B, scramble or remove, is also a static method. So we're not going to be performing, or we're not going to be calling any methods on specific objects. And that's helpful here because if we were going to be using methods on an object, we would have to know what a scrambled string object is. But because we're going to be calling methods that do something for the whole class, we don't have to concern ourselves with what a scrambled string object is, all right? And because of that, we don't need any private instance variables, and we don't need a constructor. We can just jump and take care of these 2 methods for part A and part B. So for part A, we have public static string scramble word, which takes a single parameter, which is a string. That's what we were told. Now let's focus on the 3 bullet points, the 3 key pieces of information that they give us. So it says, the scrambling process begins at the first letter of the word and continues from left to right. Okay, so as soon as I see that, or as soon as I read it and digest it, I'm thinking to myself, or you, and we should be thinking to ourselves, okay, so the scrambling process begins at the first letter of the word and continues from left to right. So we're going to have some type of loop, some type of looping process, whether it be a for loop or a while loop. And in fact, you could use either a for loop or a while loop. However, what you will have inside the body of your loop then will be somewhat different, okay? And I'll provide a YouTube link for a sample or an implementation that used a for loop. I really didn't like using the for loop for this example. Maybe that made more sense for you, but it didn't for me. So I know I'm going to be looping through an entire array, looping through an entire string from left to right, every single character, okay? Next up, if two consecutive letters consist of an A followed by a letter that is a non-A, and again, they say it right here, if. So I know I'm going to have some conditional that's testing whatever comes after the word if. So two consecutive letters consist of an A followed by a letter that is not an A. Okay, so the first letter has to be an A. The second letter has to not be equal to A. And if that's true, if that evaluates to true, then the two letters are swapped in the resulting string. Once the letters in the two adjacent positions have been swapped, neither of those two positions can be involved in a future swap. So let's go back and let's take a look at just a quick review of how to use the substring method, okay? So using the substring method, you can either use one parameter or two parameters. Now, if you use two parameters, both numbers, of course, they must be integers. The first number represents the index where you will start to isolate, n number of characters. And the second integer parameter represents where you will stop, meaning where you will go up to but not including that number. So if your range is 0, 1, then you will only isolate the first character in that string, okay? If you use just one integer parameter, it will go from that location, from that position, all the way to the end of the string, okay? So if we're thinking of this in the abstract, we're going to have something that says word.substring index, index plus 1, because that will give us the first letter, and then we're going to have word.substring index plus 1, index plus 2. That'll give us the next letter. Okay, so we'll be able to shift from left to right, focusing on a specific character, testing to see whether or not it's equal to A, and then checking to see whether or not the very next character is not equal to A. All right, so I'm going to use a while loop, which means I need to declare and initialize my index prior to the loop, which I've done here in line 25. Next up, we know that the return type of this method is string. So I want to return some string at the end of my method. But in order to do that, I have to declare and initialize some variable that will be returned at the end. So if I'm going to be returning result at the end, I need to declare and initialize it at the beginning. So in line 26, that's precisely what I've done. Next up are while loops. So we're told in the first bullet point that we're going to begin the scrambling process from the first letter, which will be at index 0, and we're going to continue it from left to right until we've gotten to the very end. So your gut or your intuition might tell you that we're going to need to loop from 0 all the way to the last character in the string, which will be at word.length -1. Now, if that's the case, then you might be thinking, okay, well, this must be less than or equal to, because we want to evaluate that final character in the string. What you will find is we're going to run into sort of a balancing act here of trying to counteract certain problems that we run into. So because in the body of the loop we are referencing index and index plus 1, okay, that's not the problem. The problem is the consecutive letter, the adjacent character. In order to reference that, we must say index plus 1, comma, index plus 2. Now, index plus 2 is at the very end of the string, is going to fall outside or give us an out of bounds exception error. So to counteract that, we must say word.length minus 1. Now, we need to keep this in mind because this is going to create a problem for us later on where we may or may not be missing a character at the end of the string, all right, which is why this conditional from lines 43 to 46 must be in play. But we'll worry about that later. So let's just worry about or focus on satisfying the conditions that were given to us in those bullet points. So the second bullet point, if two consecutive letters consist of an A followed by a letter that is not an A, okay? So word.substring, if word.substring, index, comma, index plus 1. So that's going to get that first character, dot equals capital A, and ampersand, 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 ampersand for end, word.substring, index plus 1, comma, index plus 2, dot equals A. Now, we want does not equals. So notice I've included the exclamation point prior to word. That negates word.substring index plus 1, comma, index plus 2 dot equals A. So it's like saying does not equals, okay? There is no method for does not equal, so we must include the exclamation point prior to word.substring, etc. Okay? So now we've satisfied the first part of the second bullet point. Now the then part, then the two letters are swapped in the resulting string. So result, which is what we're going to be adding on to or concatenating to, result equals result plus, or we can say in shorthand, result plus equals word.substring index plus 1, index plus 2. So this is the second letter, the second of the two consecutive letters. We want that letter to come first now because we're swapping them. The second letter is now going to be the capital A, which was, of course, the first letter. Now, you don't have to put the capital A here. If you want, you can keep it consistent with what's in the conditional, and you can write word.substring index, comma, index plus 1. Okay? It's implied that word.substring index, comma, index plus 1 is a capital A. Okay? The reason being is we don't get to enter the body of this condition unless the first character in the string that has been isolated was an A. Okay? So either way, in line 32 here, I can write word.substring index, comma, index plus 1, or I can just make it a capital A, which makes this a little bit shorter, a little bit quicker. Okay? We're then told that once the letters in two adjacent positions have been swapped, neither of those two positions can be involved in a future swap. So let's focus on abracadabra for a moment. The A is at position 0, the B is at position 1. So to start, index is 0, okay? So the A, right, index and index plus 1, so this does equal A. The B here does not equal A, so we're going to swap these two letters, which is why we have BA here. Now, because we swapped those two letters, the index value is 0. We don't want to now land on the A. So if we were to just say index plus plus, now we would go from an index value of 0 to an index value of 1. And thus we would land on the A. And we would end up satisfying that condition again, and we'd end up swapping the A and the R, which we don't want to do. And then we would continue to land on the A, and what would happen is all of the A's would get pushed to the end, and all of the non-A's would get pushed to the front. So because we don't want to evaluate the same letter twice, we have to increment the index by 2 if 2 letters have just been swapped. So we jump from an index of 0 to an index of 2. So now we are evaluating the R, okay? So that's why we have index plus equals 2. So index equals index plus 2. Now that if we're using the abracadabra example, we're focused on the R here, okay? R, which is at position 2. Now, we want to basically do the same thing we did, or something very similar to what we did in the first part of this condition, in the else part, if the 2 letters don't satisfy these conditions here, okay? So for example, let's say we have a non-A in the letter that we've now isolated. Our goal, or our objective, is to simply put that letter back in place where it was, and increment index by 1 and move over to the next letter. So that's precisely what you see here in the else, which is result plus equals word.substring index, comma, index plus 1. So we said that at the present moment, the index value is 2. So this would give us word.substring 2, comma 3. Word.substring 2, comma 3 would isolate the R in abracadabra, the first R, that is, and would concatenate that to, or add that, or append that on to the result. So we now have BAR. Index gets incremented by 1. We come back up to the while loop. So index is now 3. So now we're on to the next character, which happens to be an A. And this would then satisfy this condition here again. So we have A does equal A, so that's true, and C does not equal A, so that's true. True and true makes true. So we re-enter the body of this part of the first part of the condition. We swap the letters, so the C now moves into the third index position, or index value 3, and the A swaps over to where the C was at index value 4. And we can see that here. So we now have C at position 3 and A at position 4. And when I by position, I'm referring to the index, okay? So we can see now that the C and the A have swapped. Now, our index value was 3. We have to increment the index by 2, making it 5, which brings us over to 0, 1, 2, 3, 4, 5. So we're on to another A. So again, that's at position 5 is an A, at position 6 is a D. So that makes this true again, true and true. So we enter the body again. And so we perform the swap once again. The D moves to where the A was. The A moves to where the D was. So now we have D, then the A, and we continue the process. Well, let's just finish it, because you're going to see why we need this here at the end, okay? And I'll post my code, and I included actually a breakdown with notes of each iteration through. So actually, I can just focus on it. Well, actually, I'll leave that there. We'll just keep talking through it. So we said that we just swapped the D and the A, where the index value was 5, 0, 1, 2, 3, 4, 5. So we just swapped the A and the D. So we have to increment the index by 2, making the index 7. So we get to another A. Okay, we get to another A. Let me just confirm that. 0, 1, 2, 3, 4, 5. Okay, so we swapped the A and the D. Yes, so we're on to another A. And we are going to increment index by 2, making it 7. So that evaluates the true again. because A is equal to A and B is not equal to A. So what happens is the A and the B swap. Okay, so the A and the B swap. So we have B at position 0, 1, 2, 3, 4, 5, 6, 7. So the B gets inserted at position 7, and the A gets placed at position 8. So we increment the index again by 2, making it, where it says current, it just means index. Okay, I'll change that to index. So the index is now 9. So we're at position 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're at the R. R does not equal A. So we have a short circuit evaluation. That condition is false, which means we execute the else part. So we keep that letter in place. So the R remains where it is, index plus plus. So the index now becomes 10. Now here's the problem. The length of the word abracadabra is 11, okay? But because we had to keep this balanced by subtracting 1 from the length of the word so we wouldn't get an index out of bounds error, we stop evaluating the string, the original string, before we've looked at all of the letters. So we end up with an index of 10. 10 less than 10 is false. Okay, 10 is not less than 10. So we don't get to re-enter the body of the loop, and thus we would end up with bar, cad, ab, r. Okay, this final A would get left out. And if I go ahead and just take this out for a moment, okay, and run it, you'll see that that will happen. Okay, so notice the A here on the woe, the aardvark is missing the K here, eggs becomes egg, A becomes blank. So we're missing some things here, okay? And again, the reason being is because we had to counteract the out of bounds exception error by saying index is less than word dot length minus 1. Now, to balance that back out, we need to include a condition that states if the index is less than word dot length, okay, notice not word dot length minus 1, just word dot length, then we are going to add on to the result word dot substring index. So notice how I just have one integer parameter here. And remember, when you have one integer parameter in the substring method, it goes from that position all the way to the end. So anything that was left out will be appended onto the end, which is only going to be just the one letter. Okay, it's just going to be the one letter. Okay, and that's why we need this condition down here at the bottom. And now that I've brought that back, I can go ahead and run this, and you will find that those letters are no longer missing. Okay, the A is back, the A is back, the K is there, the S is there, the A is there. Okay, and that is our scramble word method for part A. Are there any questions related to part A of this question before we move on to part B? I felt like part A was much more difficult than part B. I thought part B was a lot easier, actually. Any questions before we move on? All right, moving on to part B then. If you think of a question later on, just type it into the chat and I'll address it as soon as I can. All right, so part B, we're told to write a method called scramble or remove, which replaces each word in the parameter word list with its scrambled version and removes any words that are unchanged after scrambling. The relative ordering of the entries in the word list remains the same as before the call to scramble or remove. The following example shows how the contents of word list would be modified as a result of calling scramble or remove. Before the call to scramble or remove, word list will be tan, abracadabra, whoa, apples, or apple, and eggs. After the call, scramble or remove, the word list will have tan becomes TNA, abracadabra becomes barkadabara, and whoa gets removed, okay? Apple becomes papal, and eggs gets removed. So notice that whoa and eggs both get removed because when the scramble method is called upon them, they return the same string, and we can observe this from part A. Notice whoa becomes whoa and eggs becomes eggs. So we're told in the instructions that if a word does not scramble, then you have to remove it, okay? All right. So scramble or remove. I'm using a while loop once again, which means I'm going to have to declare and initialize my index variable prior to the loop. So while the index is less than wordlist.size, I am going to have a word that, I'm going to have a string that is represented by a variable called word, and that is assigned to wordList.getIndex, okay? So this is going to get the word from the list for me. WordList.getIndex gets the object, I should say, from the list. The object in the list happens to be a string, and we're storing that in a variable called word. Now, we're going to have another variable called scrambled, which is also a string, and we're going to make a call to the scramble word method that we implemented in part A. Now remember, here is again another, advantage to not using or not worrying about using an IDE like Replit. You can get full credit on part B without even doing part A. You are to assume that whatever implementation you wrote for part A works as intended, meaning whatever you wrote for part A, you're to assume that it works correctly, okay, even if it doesn't. All you need to do in order to answer part B correctly is understand what the scramble word method does. So we're going to store the new word, okay, the scrambled version of the word, in this variable called scrambled. If scrambled equals the word, the original word, then you want to remove that word, okay? Remember, whoa became whoa, so we want to remove that word. Eggs becomes eggs, so we want to remove eggs from the list. Now, what happens when you remove an element from the list? What happens to the size of the list? And what happens to each subsequent element that comes after the element you've removed? Exactly, okay? Exactly. So because the remove method shifts each subsequent element one space to the left, we will then be focused on, okay, the next element in the list, which is why we're not going to increment index if we've just removed an object from the list, then we don't want to increment index, okay? We will then come back up. The index will remain the same, but the word that is now at that specific index will be different, okay? Because the word that was at that index has now been removed. So everything shifted over. Now, if the two words are not equal, then we execute the else part, in which case we'll have to use the set method, okay? Word list.set, at that specific index, you will place the scrambled word, okay? Because at that position, at least at the moment, is the original word, the unscrambled version. We don't want the unscrambled version at that part. We want the scrambled version. And then, of course, since we didn't remove anything, you want to increment the index by 1, which will then lead you to the next word or the next object in the list, and we continue evaluating until we get to the end of the list. Okay, and that's it for part B. Jay, to answer your question, what I'm doing here is dissecting these questions with you at the the highest level possible. So I'm trying to hit on as much as I can with you, and I'm trying to show you, at least in practice, how you can test these things. Okay. Instead of me just sort of like handwriting them or writing them in like a Google Doc, right? If I wrote the solutions out in a Google Doc, then I wouldn't be able to provide any evidence to you that they do in fact work, which is why I'm typing them up in an IDE. I've said many times that there may only be a handful of you that using an IDE will be successful in doing so, because I've said, of course, there are the time constraints. So I think that what we're doing here is helpful in that, you can spend hours on a question really dissecting it and learning from it, I guess, sort of the, whether or not there are any connections from one FRQ to another, and there are. But yeah, I really don't think for most of you using an IDE will be useful. Okay, so my tip for you is to practice writing your solutions first, either by hand or in a Google Doc that just answer the question, and then once you've written them, then put them into an IDE where you have the full class so that you can test them, right? And you can self-assess and you can get feedback. The IDE gives you feedback about the implementation of your methods. Okay, so I'm not there to check it right away as soon as you've finished, but when you've written the implementation, if you have a full class and in the main method you have you're using those methods appropriately, you can test them out and you can get that feedback and see whether or not what you wrote is working. Okay, so without the IDE, and of course you can go on to the AP website and you can get all the solutions, but the solution you wrote might not be exactly what they have, and that doesn't mean what you wrote is incorrect, which is why I've been encouraging the use of the IDE, but not necessarily using it from the start. Yes, Clementina. So first, I have an array of words. Okay, this is for part A. I've used a for each loop that just simply prints the word, and it says tan concatenate becomes. I made a call to the scrambled word method. Now again, remember, scrambled word method is a static method. So scrambled strings, which is the name of the class, followed by scrambled word, the method, which takes in a parameter, which is an array of strings. Okay, and we can see that in part A. It takes in a string. okay? So for each, rather, word is not an array. Word is an individual string from the words array, okay? For part B, I had to declare and create a list of strings. I added each one of those words to the list. I then used my for each loop again to print out each word: tan, abracadabra, whoa, apple, and eggs, just to make sure that they were all there. I then had a system.out_print after scramble or remove method is called, scrambled strings dot scramble or remove word. So each word will be processed. Each element or each object in the list word will be processed. It'll be either scramble or removed. I then used another for each loop to print out each one of those elements, and we can see tan became TNA, abracadabra became barcad abara, and whoa got removed, apple became papal, and eggs got removed, okay? Back to your question, Jay. One of the things that you'll notice with every FRQ is that these notes here are the same for every single question. Assume that the classes listed in the appendices have been imported where appropriate. So you can have that memorized. There's no sense in reading it. There's no sense in reading this. Okay, show all your work. Remember that the program segments are to be written in Java. That's the same for every single FRQ, every single set of FRQs, and the notes are always the same here. Okay, so it's like on an SAT. There's no sense in reading that because it's the same thing every time. So you should know it ahead of time. In terms of breaking down the question, the key really is to just practice as many of these problems as possible. Okay. So efficiency in the way that you think and the way that you break these problems down, the best way to do it is just simply practice as many of them as possible. So once you've completed the questions that I've posted, then it's time to go back and do them again. Okay, and then once you've done them, then you do them again. And it's not like a math problem necessarily where you have the answer memorized and you can just regurgitate it very easily. I think that you'll find that even though you may have done many of these problems already, if you start them from scratch, you'll be able to do them quicker, but it's not like you're going to be able to do them in 5 seconds where you had all of the code memorized. It requires you to really think. But there is a style in the questions in the way that you are required to think. So the more you practice, the quicker you'll be able to process the information. That's really all there is to it. It's like anything you do. The more you practice, the better you become.